Hi folks, so this is question 9. So Brian buys a car. So basically he buys a car and then the value of the car depreciates. So depreciates means the value goes down. So you should know that when you buy a car, the price of it will go down every year a little bit. Uh, the older it gets, because older cars aren't worth much. So this graph means that along the bottom is the number of years. So this 30 here at the top, so it starts at 30, so that means the car is worth 30 grand when it's new. But then once it goes on, so once you hit 1 year here, the price of it has gone down, and now it's only 24,000. And then after another year, it's between 18 and 21, so it's about 19,000. And then after 3 years, it's only worth 15,000. So you see there, after 3 years, it's only worth half of what it was at the start. So that's what the graph means. So use the graph to write down V of 0, the initial value of Brian's car, and V1, the value of his car after 1 year. So you'll see here in the graph, the initial value of the car was 30 grand, we just said that, and then after 1 year it's 24 grand. So 30 grand and 24. So first, show that the value of the car will reduce by 20% in its first year according to this model. So if the value of it at the start was 30 grand, then it decreased by 20%. So we have to work out what's 20% of 30,000. So to work out 20% of it, you could multiply by 20% like that on your calculator, or you could change it into a fraction, just multiply by 20 over 100, or you could multiply by 0.2. But whatever way you do it, you should get 6,000. And then that does work out, because 30,000 minus 6,000 is 4,000. And it is valued at 24,000 after 1 year. So we've shown that. Based on this model, write a formula for V of t. So V of t is just the value after how long, after a certain amount of time. The value of Brian's car after 2 years in terms of the age of the car. So use the fact that the value decreases by 20%. So it's going to have to be 30,000. Now it uh, it decreases by 20% each year. So if it decreases by 20%, you're left with 80% then every year. So you're left with 80% each year. So it'll be times by 0.8. I'm just changing into a decimal. And then the t always goes as the power in these kinds of questions. So that's how many years then. So it'll be 30,000 times 0.8 power t. And that's the formula. Hence or otherwise, work out the value of Brian's car after 4 years. So then we just have to use that formula. So it's 30,000. So then after 4 years means you just have to put in a 4. So you put in uh, whatever amount of years you want instead of t. And I'm getting 12288. So that's how much it's worth then after 4 years. So if you look back up this graph, then it should be about that 12288. Oh, I had put in a 0 instead of an 8 there actually. 12288. So it should be about that after 4 years. Yep. Okay, so Right, so a different linear model assumes, so it gives a new graph here, and a different linear model assumes that the car reduces by a fixed amount each year. So the value of the car will also reduce by 20% in its first year according to this model. Draw a line on the diagram above, passing through the first 2 points on the graph. So the whole number values of t, so t is 0, t is 1. Continue your line until it reaches the horizontal axis. So that's very straightforward. All you have to do is draw a line. So you have to draw it through that point there and through this point here. So if you draw, so you need to use a ruler. Obviously, I'm only doing this roughly. So I'm getting close to 5 there, I think. Hence or otherwise estimate T, the age Brian's car, when its value would be €0. So when it's €0, I mean it's where it crosses the line here. Uh, so it's 5. So it's after 5 years. So that red line basically means if the car goes down by the same amount each year. In the one we're doing here, doing just above, it goes down by a percentage of whatever it was. But now it's going down by just the same amount each year. And if that was the case, it would, after 5 years, it would be worth 0. Eva buys a new car that has a price of 19,445. Pays 30% of this price as deposit. Okay, so we have to work out the value of the car really. So we do 19,000. And she pays 30% of this price as a deposit. So you can times that by 0.3 or times it by 30 over 100. And that will be the price of the deposit. Okay, and then she makes repayments of 200. So we have to add on then 206.97 per month for 3 years. So in 3 years, there's 36 months. Yeah, she has to do 36 of these, 36 of 206.97. And then at the end of 3 years, she also pays a lump sum at the end. So she has to pay another 7,389 then. So that's it then. That's the total cost of the car. So the first part we did there, that's the deposit. And here is the monthly repayments. And then this last bit, that's a little lump sum she has to pay at the end. Finish it off, pay the whole thing. So you can just put all that into the calculator together then. And I'm getting 205.3992. That's the total cost of the car then. She drives her car home from the garage at distance of 12 kilometers. So this is a distance speed time question. So that triangle's always handy for your formula. So speed is distance over time, time is distance over speed, and distance is speed multiplied by time. So she usually drives home at an average speed of 60 kilometers per hour. On this day there's road work, so her average speed is only 40 kilometers per hour. Work out the percentage increase in the time it takes Eva to drive home. So usually, um, so we're looking at the difference in time here. So usually the time would be the distance over the speed. So it would be 12 over 60. That would usually be the time. So that would be 0.2 hours. Um, so just say this day, on this day, or this other day then, where there's roadworks, the time would be, well, it's still the same distance. You're still driving home the same distance, so it'd be 12 over 40 this time. So 12 over 40, 0.3. Yeah, so it's 0.3 hours. So that's the difference then. So the percentage increase then, well, there's a difference of 0.1 out of the 0.2, and then you times that by 100. So, or you can kind of just see that uh, on this on this day that there's roadworks, it's taken the 0.2 hours again, which is 12 minutes. It's taken that again, but then it's taken an extra kind of half of that again. So it's taken on the day it has roadworks, it's taken the 0.2 hours, but then it's taken another 0.1 again. So 0.1 is half of 0.2. It's going to be 50%. 50%. And that's everything for question 9.